to Intelligence Gateway.
Module 2, Machine Learning. Machine learning is a field of artificial intelligence that focuses on the development of algorithms and statistical models that enable computers to automatically learn from data and improve their performance on a specific task. In machine learning, computers are trained on large datasets to identify patterns and relationships, which can then be used to make predictions or decisions about new data. Overview of machine learning and its applications. Machine learning is a subfield of artificial intelligence that focuses on developing algorithms and models that can learn from data and improve their performance over time without being explicitly programmed. Machine learning techniques are used to extract patterns and insights from large datasets, which can be used to make predictions, recommendations, or decisions. Some applications of machine learning include image and speech recognition. Machine learning algorithms can be trained to identify objects and images, recognize faces, and transcribe speech into text. Natural language processing. Machine learning can be used to extract meaning from text data, such as sentiment analysis, language translation, and chatbots. Predictive analytics. Machine learning algorithms can be used to make predictions about future events based on historical data, such as sales forecasting, risk assessment, and fraud detection. Recommendation systems. Machine learning can be used to recommend products or services to users based on their past behavior or preferences, such as personalized movie recommendations or product recommendations on e-commerce sites. Autonomous vehicles. Machine learning algorithms are being used to develop self-driving cars that can learn from their environment and make decisions in real time. Overall, machine learning has a wide range of applications across industries and is increasingly being used to automate and optimize business processes, improve customer experiences, and drive innovation. Data preprocessing and feature engineering. Data preprocessing and feature engineering are important steps in the machine learning workflow. These steps involve transforming and preparing the raw data so that it can be used to train machine learning models effectively. Data preprocessing involves cleaning, transforming, and normalizing the raw data to make it suitable for analysis. This may involve handling missing data, removing outliers, normalizing the data to a common scale, and encoding categorical variables into numerical values. Some common techniques used in data preprocessing and feature engineering include data cleaning. This involves handling missing values, removing duplicates, and dealing with outliers. Data normalization. This involves scaling the data to a common range or distribution to reduce the impact of different scales in the input features. Categorical encoding. This involves encoding categorical variables as numerical values that can be used in the machine learning models. Feature selection. This involves selecting a subset of the most relevant features for the machine learning model to improve its performance and reduce the risk of overfitting. Data preprocessing and feature engineering are critical steps in the machine learning workflow because the quality of the data used to train the model has a significant impact on its performance. By carefully preparing and engineering the data, machine learning models can be trained to accurately predict outcomes or classify data. Model training and evaluation using different algorithms. Model training and evaluation are critical steps in the machine learning workflow and involve selecting an appropriate algorithm, training it on the data, and evaluating its performance. There are a wide range of machine learning algorithms available, including linear regression, used for predicting continuous values, such as house prices. Logistic regression, used for binary classification tasks, such as whether a customer will churn or not. Decision trees, used for both classification and regression tasks, and are good at handling nonlinear relationships. Random forests, a type of ensemble algorithm that combines multiple decision trees to improve performance. Support vector machines, SVM, used for classification tasks, and are particularly useful when dealing with high-dimensional datasets. Once an appropriate algorithm has been selected, it is trained on a portion of the data, called the training set. The model is then evaluated on a separate portion of the data, called the test set, to determine how well it generalizes to new, unseen data. Common evaluation metrics include accuracy, precision, recall, and F1 score for classification tasks, and mean squared error or R-squared for regression tasks. To improve the performance of the model, hyperparameters can be tuned, which are settings that control the behavior of the algorithm. This can be done using techniques such as grid search or randomized search. Additionally, different performance metrics can be optimized depending on the task at hand, such as minimizing false positives in a cancer diagnosis system.
Thanks for watching. For more information, like, comment, and subscribe our channel.